Hello, hello. Today we are looking at finding solution sets to systems of inequalities this time. So basically we're going to take what we did yesterday, or Friday I should say. We're going to graph an inequality, except we have a system, so we're working with two inequalities at one time. So that shaded region, well, we're going to be looking at where is the shaded region that both inequalities share, or do they share anything at all? So let's go ahead and get started and look at our first one. We have x plus y is less than -1. Okay, so can I graph this right now? It is not slope-intercept form, so nope, I want to put it in slope-intercept form. So I'm going to go ahead and subtract x. So I have y is less than, so mx plus b, I want my x term first, so -x, and then a -1. All right, so I'm going to start with that one. So I'm going to go ahead and graph. So I look for my y-intercept of -1, plot that point. Now from here, what's my slope? So I have a -x. So what coefficient is that in front of it? -1? So I have -1 over 1. So that tells me from my y-intercept, I'm going to go -1. So I'm going to rise -1. So really I'm going to fall -1, and I'm going to run 1. So -1, +1, -1, +1. Now that I have a few points, I'm going to go ahead and graph. So remember, with inequalities, we have to focus on our inequality symbol. Is it open or closed? So since it's less than, it is not equal to, it's open, so I need to designate that using a dashed line. Okay, so now inequalities have a lot of solutions. So the solutions are not on this line. So 0, -1 is not actually a solution. It won't make that statement true. But all of the stuff less than it will. So since it's less than, I'm going to shade below my line. Cool beans? So let's do the same thing for the next one. So I'm going to graph -2x plus y is greater than or equal to 2. Okay, so isolate y. So we need to move this -2x. So my inverse operation, +2x. So y is greater than or equal to, so mx, 2x, and then a +2 plus 2. All right, same rules apply. Slope-intercept form. So I've got a +2, start there. So my y-axis at +2. And my slope is 2, but I need to rise over run. So what can I put it over that won't change it? 1. So I'm going to rise +2, so up 2 and right 1. Up 2, right 1, out of room. I'm going to go the opposite way. Okay, and this is greater than or equal to. So I have a nice solid line. Oh, that's off a little bit. Well, let me move it. No, I didn't think so. Okay, I give up. So we're going to assume that that's actually over the points and shade greater than, so shade above the line. So when we're looking for the solution set to the system, it has to be a solution to both inequalities. So the only place where that happens is where the shading overlaps. Now, a couple tricky things they could ask you. They could say, is -2, 1 a solution? No, it's not, because that's on my green dashed line, so that would not be a solution. Now, is -2, -2 a solution? Yes, because that lies in my green stuff and it's falling on a solid line, so that one would work. So that's probably the trickiest of the examples. Any other point in this double shaded region is a solution to both inequalities, which makes it a solution to the system. Cool? So I want you to go ahead, and if you're feeling comfortable, I want you to go ahead and pause the video and try the next one yourself. Alright, so let's see if you get the same thing as me. X plus y is greater than or equal to 2. So real quick, isolate y. So move over our positive x. So I'm going to subtract x. So y is greater than or equal to negative x plus 2. So my y-intercept, positive 2. My slope, negative x. So again, negative 1x. So rise over run, I'm going to put it over 1. So negative 1 over 1. Down 1, right 1. Down 1, right 1. I'm going to do the opposite, so I have a couple more on this side. And it is equal to, so I have a nice solid line. Why won't it let me move it? Oh, sweet, it did that time. Okay, so y is greater than, so if I look at my line, I want to shade everything above my line. So there's all our solutions to the first inequality. All right, cool. So now let's look at this next one. So negative y is greater than x plus 4. Now this is almost in slope-intercept form. I have my mx and my b, but I have negative y, and I don't want to know what negative y is. I want to know what y is. So I need to get rid of this negative. Remember, that's a negative 1 times y, so I'm going to go ahead and divide each of my terms by negative 1. Now remember, inequalities are very similar to solving equations. The only difference is multiplying or dividing by a negative. So we did divide by a negative, so you must remember when we divide by a negative, we have to remember to flip that sign. So important. So I end up with y is less than negative x minus 4. So again, flipping that sign, that's key here. That's the common mistake people make. So go ahead and graph, plot your y-intercept, negative 4. And look at our slope. So again, negative x, so negative 1x, negative 1, put it over 1. So rise over run, down 1, right 1. Down 1, right 1. Remember, we're going right because it's a positive in the denominator. If it were negative, we'd go opposite, we'd go left. So I want to continue in the opposite direction, so I'm going to go up and left, up and left. And this is just less than, so we need an open or a dashed line. And we are shading everything less than, so everything under our line. Cool? Wait a minute. Not cool. What is the solution to this system? All my blue stuff is shaded over here, all my pink stuff shaded over here. Do they have anything in common? No. So this is an example of, you guessed it, no solution. I guess I should say no solutions, since it's an inequality and there's usually a lot of them. So there's no solutions that will satisfy both inequalities at the same time. It's just not going to happen. So that's the difference there. Awesome? Okay, let's take a look at a real-world example. Alrighty, so we are given the situation that every week Jane works at Starbucks during the day and at a youth dance class at night. She can work a maximum of 40 hours a week. She calculates she needs to earn at least $368 every week to cover her expenses. So Jane earns $13 an hour at Starbucks and $9 an hour at the youth dance class. So let's see what they want us to do. So first, write a system of linear inequalities to represent the situation. Okay, so let's write a system. So we got a couple different things going on. So every week, Jane works at Starbucks during the day and youth dance class at night. She can work a maximum of 40 hours a week. Okay, so that's going to be important. She calculates she needs to earn at least $368, 13 at Starbucks, 9 at youth dance class. Okay, so remember, when we have a system, when we have two different pieces, categories, it kind of depends on the problem, but two different situations within the same problem, we kind of have to figure out how to split them up. So when I look at this, the first thing I see is money, money, money. So all of those three money pieces are going to go in the same inequality. So we need to earn at least 368. That at least is key, so I'm going to circle that too. And how we're going to make that? $13 an hour at Starbucks and $9 an hour at dance class. Okay, so I'm going to start there. So we need to earn at least 368. So at least. So what do I need to use? Less than 368 or more? At least. Okay, that's going to be greater than 368. Now, can I earn 368? At least. At least 368. So yeah, I can earn 368. So I need to have an equal to. And how do I do that? $13 an hour at Starbucks. So 13S plus $9 an hour at dance class. 9D needs to be greater than or equal to 368. Cool? All right. Now, what was the other piece of information that was given? She can work a maximum of 40 hours. Okay, so she can work a maximum of 40 hours. So maximum, so can she earn more than 40? Or can she work more than 40? No, that's a max. So she needs to earn less than 40. Can she work 40? A maximum of 40. So yes, she can actually work 40. That's okay. So less than or equal to. Now, what makes up those 40 hours? Where is she working? Starbucks and dance class. So we have now successfully set up our system. Cool beans? Okay, let's look and see. It says, which of the following combinations satisfy the situation? Select all that apply. All right. So 32 hours at Starbucks and 9 hours at the dance class. So which inequality are we looking at? Well, we're looking at the hours inequality. So if she works 32 and 9, well, wait a minute. What's 32 plus 9? That's 41 hours. That's more than 40 hours. So no, that can't even work. We don't even need to plug that in because it's probably going to exceed the 368 like she needs to, but it's going to max the number of hours, and she's probably still got school and everything else. All right, so let's see. The next one, 30 hours at Starbucks and 5 hours at dance class. Well, let's figure out how much is she going to make. So 30 hours at Starbucks, that's where she gets paid $13 an hour. Let's see, that's $3.90. Plus, do I even need to keep going? Not really, because I already know that she's going to make more than the $368. 30 and 5, so she'll stay under her 40 hours. So that one definitely works. This next one. 25 hours at Starbucks, 4 hours at the dance class. Okay, so she's under her 40 hours. So 25 hours at Starbucks. So 25 hours at 13 gives us $325 plus 4 hours at dance class. So for, what is that, $9 each? So plus another 36. Uh-oh. Is that going to be enough? Add those up? Nope. She only makes $361 that week, so that would not be a good combination. So 19 hours at Starbucks and 13 hours at dance class. 19, 20, 30. Okay, so we're under the amount. So 19 hours at Starbucks. So 19 at the 13 gives us $247. Plus 13 hours at dance class. So 13 hours at $9 each. So $117. So is this one going to work? Add those up. 364. Again, not enough. All right, 15 hours at Starbucks, 20 hours at dance class, so 35 hours, so we're still under the 40. So let's see if that'll work. So 15 hours at 13 each gives us 195. And then 20 hours at the dance class, so 20 times 9 and 180. So that gives us a total of $375. All right, we did exceed our $368 that we need. Sweet. Last one, 10 hours at Starbucks, 26 hours at dance class, so that brings me to a total of 36 hours. That is allowed. So 10 hours at $13 each, so $130. Color. And then 26 at dance, so 26 times 9 to 34. So that gives us a total of 364. Just shy, so not enough. So that will not work. So it says if Jane works 22 hours of Starbucks, what's the minimum number of hours she needs to work to cover her expenses and why? So which inequality am I going to be using? So remember, it's asking we need minimum number of hours to cover her expenses. So that was at $368 is her expenses. So $13 at Starbucks. So she says she works 22 hours at Starbucks. All right, so we need to figure out how many hours at the dance class does she need to exceed the $368. Okay, so 13 times 22 gives us $286. And I'm just solving this as if it were an equation. So I'm going to solve for D, isolate D. So I'm going to go ahead and get rid of this 286. So I'm going to subtract the $286. So $9 per dance class needs to be greater than or equal to $82. All right, that doesn't seem too bad. I shouldn't have to work too much more. Well, Jane. So divide both sides by 9. Let's see. She needs to work. That does not go in individually or evenly. So it says greater than or equal to 9.1. Is that an acceptable answer for this question? No, she's not working 9 hours. So she needs to work more than 9.1 hours. So at the dance class, I'm thinking they're probably not going to be okay with it if you just show up for 10 minutes. So she needs to work greater than, so what's the minimum number of hours she needs to work? Is 9 hours acceptable? No, like 9 hours won't be enough. It's going to be like this one where she comes up just a little bit shy at like $364 or something like that. So she needs to work at least 10 hours at dance class. Okay, so for these inequalities in the real world, a lot of this is just plug and chug. See which one works, but also make sure it's got to satisfy both of the inequalities, because this first one probably would have exceeded the $368, but it also exceeds the $40 that we're not allowed to exceed. So it's got to make sure it satisfies both inequalities. All right, so give your homework day 10 a shot and see how it goes.